Should have asked you if anybody want to swear or something before we start. Okay. General information for electrical installation. Some of you guys will ask your designers, you say, why, Chad, should I know about lockout, tagout? Why should I know about using tools and safety and all this good stuff? Because as you know, unless you're electricians and you're going to work as an electrician in the state of Minnesota, you cannot, shall not, will not legally carry tools and work on equipment. We are not, this program is not, it does not qualify you to carry tools, guys, and work on equipment. But you will be a project manager, project estimator around the electricians. So it's really nice to always understand the safety when you work around electrical equipment. And if you want to be an electrician, no problem. You can put your apprenticeship and you get your license and so forth. I'll talk about licensure in a few seconds in Minnesota, guys. But that's why we like the safety. Yes, you're not carrying tools, but you will be in a situation where you will be around electricians opening live equipment, 4,000 amp switchgear, open the cover on it, and you're sticking your head right there because you're going to take a couple of pictures. So you can go to the office, modify that switchgear to add another 600 amp feeder out of the switchgear. I've done it many times. A lot of people guys do that. So you need to be able to understand what is the gravity of sticking your head in a switchgear, a 4,000 amp switchgear hot. So that's why I like this one. A couple of things about safety, guys. We're going to talk about safety. Sources of safety and technical information online is a big deal. So I don't know how many of you guys have looked at the end of this book. There is, gosh, there's close to 100 plus website that's really nice for more information. I know you guys are overwhelmed. I get overwhelmed with all this information around. But if you want to look at an electrical company that makes cables, and I gave you a lot of these sites, guys. They're also at the end of this book. He listed, I think it's probably 100 plus sites that could be beneficial at one time. Not today, maybe 5 years from now when you establish your career too. So a few things about safety, guys, a few things about research online that you're going to be doing. If we go, the single most important things basically in this book is following the NEC code 2011, because in Minnesota we adopted it August 8th. But there's also, guys, this is the most important code that you're going to be adhering to. Though, if you become a project manager, Chris, probably you've done that, OSHA and rules and regulations, that's a big deal when you become a project manager for safety. The last thing you want to do as a project manager, guys, in a job is to lose a human being, one of the electricians that are working on your job. That's the worst thing that could happen to any project manager. So a lot of safety. A couple of 70E. I don't know how many of you guys have seen 70E. 70E, NFPA 70 is the NEC code book, which is, we have it right here. Everybody's looking at it. We're going to know this inside out by the end of the year. I'm sure a lot of you know a lot about it. 70E, guys, tell you if you're working around electrical equipment hot, how do you work around electrical equipment hot and be safe? So a lot of safety stuff. If you're a designer at Ch1&2 Erickson, it doesn't mean anything to you unless you become a project manager, go work in the field, then it becomes 70, becomes a big deal, and OSHA rules. So I'm going to highlight another one, ICC, guys, the international standards. There's a lot of, if you go ICC, there's a whole international code that you can see how they do the GFCI in different parts of the country and part of the world too. I will talk a lot about permits and licensure in Minnesota because we're in Minnesota later on, and plans and specifications. We'll talk about the plans and specification, the symbols and the notes, guys, as we said. International Association of Electrical Inspectors, well-respected entity, guys. I encourage a lot of you to, to be a member as you go through. And the last thing we're going to be talking about is metric system, and you heard about metric all the time. So these are a few highlights, guys, we're going to be talking about in this chapter, that this chapter is covers. Safety in the workplace. Safety in the workplace, I can't emphasize, you guys are not, we're not training you to be electricians. To work as an electrician in the state of Minnesota, anybody knows what you need to do in the state of Minnesota as well as in many states? You need to be bonded, licensed, and insured. Legally, again, to work legally. To work legally, you have to be bonded, licensed, and insured. In our state, guys, the entity that regulates, as you know, Chris, the electrical work, it used to be Board of Electricity. Now they moved it into the Department of Labor and Industry, and it's part of licensing and inspection. It's called Licensing and Inspection Unit, Electrical Licensing and Inspection Unit. This is where they put the legislations for working in the state of Minnesota. It's the law of the land. So based on this law of the land, Phil, my friend, as you all know, to work in the state of Minnesota, you need to be bonded as an electrical company, like bond, $25,000 bond with the state, buy a bond. So if you burn something, hopefully they can pull that money and give compensation for people. Bonding, $25,000, every company at least, or more. Licensed as an electrical contractor. And license, you have two types of licensure, guys. You have to be licensed as a business, electrical contractor, and you also have to hire a master electrician. Last week I showed you my master electrician license. You have to hire somebody like Chad, or you yourself have to be a master electrician, technically responsible for your company. So bonded, insured, bonded, licensed as a company, also hire licensed electricians. One of them has to be master in the state of Minnesota, and the rest of them have to be journeymen. And insured. You have to also have insurance, guys, and there is a list of the insurers close to $300,000 for body damage and burn and all this good stuff. 3 things to practice work in the state of Minnesota legally: licensed, bonded, and insured. Very, very important to know that. Who cares, Chris? You're going to be a project manager, and you're going to be putting a job, and people are going to be bidding on it. So Ashley will come from somewhere and bid on your job. Okay, show me, are you licensed, bonded, insured? If she's not licensed, bonded, or insured, she can't bid on the job. Very, very clear in the state, as well as in many states, guys. North and South Dakota, Wisconsin, they're going to start, I believe, in, licensure for their electrician statewide on 2013, I believe, like Ashley, 2013. Can't remember when 2013, a state level. In the state of Minnesota, Chris, probably, I don't know if you, I think we've been licensing a state level since the 60s. Unreal. Since the 60s, you have to be licensed to work in the state of Minnesota. So one more thing, Dustin, about the state, because we live in Minnesota, you guys need to be aware of that one, especially from a project manager point of view. In the state of Minnesota, you have to be a journeyman electrician or master to work on equipment, to work in any electrical work. And also, you cannot supervise more than 2 unlicensed individuals. So I take Zach and Ashley with me as a master electrician to do our work. But I need another helper. Can I grab Nick as another helper? Can I? Can I supervise more than 3? No. Who cares? Talk about Phil, project manager, who cares? That's how you manage the project, guys. So that you allocate your labor. If you don't know that, but in the state of Minnesota, for every journeyman you need 2 men. You cannot have more than 2 unlicensed individuals. Then you can't manage your project. You think, well, I can hire all of you guys, non-licensed, right? None of you is licensed, and you can work with me, and we can make money. I pay you $19 an hour, versus if you're an electrician, probably you're making $33 an hour. See that? The reason why you can't do this in the state of Minnesota. The ratio is 2 to 1, licensed for non-licensed. 2 non-licensed for 1 licensed. Everybody knows that? Great for project management. That's help you not now, but for project management. So that's a few things about, guys, the laws and rules. Electrical, here's how I look at the electrical hazard. I always tell this story, guys. I've been working with the electrical equipment probably for 21 years. I got literally shocks, just a little shock, for probably 20 times I counted. And that's including when I was 17 years old and I didn't know what I was doing and I was just playing with things, horsing around. So if the most important thing is not to take it lightly. When I wire personally, if I'm wiring residential, you always have to be careful. But when you're wiring residential, I am not as nervous as if I am opening a 4,000 amp switchgear. Opening a 200 amp panel, residential, Ashley, and adding a 20 amp circuit breaker to it and pulling a circuit for a kitchen fan or pump or something, that's not as dangerous as opening a 4,000 amp switchgear and pulling a 600 amp feeder from it to feed a sub panel. So just to put things in perspective, the rule always, guys, is when you work on electrical equipment, work de-energized unless you have reasons not to. Does that make sense? You always work de-energized everything, lock it, tag it, you lock, you tag, and work de-energized unless you have a reason to. And if you have a reason to, you have to have a permit. A lot of electrical companies, they ask you to have a hot a permit to work on equipment hot, so multiple guys have to sign on it. You have to have the PPE, the proper PPE to work on it, and a bunch of guys have to sign on it because that's when the most dangerous part you're going to be exposed to the most dangerous when you're working on things hot. So if I have to say something, what scares me when I work as an electrician, guys, is not electrocution, because we're all smart not to touch anything. I hopefully when you become a master and a journeyman as an apprentice, you're smart not to go grab on something, a wire, right? I hope. But I don't think a lot of us are smart on avoiding the arc blast. For example, a lot of us guys will open a 400 amp panel and start adding a 3 amp circuit breaker in it. And they're not dressed up with the proper PPE. Now, okay, up to this point, no problem. If you are too short, suppose that you drop the circuit breaker, say one of your tools dropped right inside this panel and you short it. You're not touching anything. There will be a big ball of fire coming out of that panel. That big ball of fire, if you're too close and you're not wearing the right protective gear for your eyes, you could lose your eyes easily. You could burn your face. So that's what the arc blast. I always like to tell a story, Phil. I said I've been in a lot of places where they hire us to go modify switchgear. Always when we modify switchgear. So we can't open the switchgear as engineers. So you hire an electrical contractor to come and open the switchgear for you. So you will see an electrical engineer standing right next to the electrician. The electrician is dressed up with the PPE, and the engineer is right behind them taking all these notes. And the electrician is dressed up, but the engineers are not. So my point for you guys is, when you see what I would do, because we're not licensed to open the panels, when I go as an engineer, when the electricians are opening a panel for you to look inside the switchgear to modify it, the first thing you need to do is keep away from the electrician while they're opening the panel hot. Remember, you're just going there not to work. Take pictures. But it could be as he or she are opening the panel, they drop a piece of tool, big arc flash comes, what's going to happen to you? You're not dressed up, but he is or she is. You could be burned. So these are the rules that you guys, if I have to emphasize one little thing, I always emphasize the blast, arc flash. The voltages that we use in the US, guys, as you know, 240, right? 240/120. Probably 90% of the time you're going to be with this voltage. In apartments, when you go higher apartments, they use also 208/120 volt 3-phase system. This is single phase, right? This is single phase system. These are the most common voltages that you're going to be using in residential. If you think you're going to be using 480/277 here in residential, you're probably wrong for the most part. This one for single family dwellings and small apartment building, 240/120, very common. You get into risers, 10-story building and so forth, you start moving in 208/120. More power, more juice. Any question, guys? 99% of the time, guys, when you do residential homes, 99% of the time, you have 100 amp or 200 amp. That will cover 99% of any home in the US. For 95%. Either 100 amp or 200 amp at 240/120. Apartments are different. You can have an apartment with 600 amp service or 1,000 amp service or 2,000 amp service. Apartment building. So that's a few things, guys, about electrical. As I said, guys, you've done that with us, the electricians who came. Lockout, tagout. You physically protect anybody from accidentally or intentionally de-energizing a piece of equipment while you're working on it. That's the whole lockout, tagout. So if I'm working, you guys look at that switch right there, you turn it off and you could lock it with your own lock and tag it with your own tag, and only you can unlock that piece of equipment while working on it. Who cares? In the past, guys, people used to stick their hand and they leave their hand behind in these mixers when they're working on them. And it's not for electricians, for all the construction and manufacturing people who work with these pieces of equipment. I'll show you later on when we go to the commercial into North Star Steel. They have a big, they take your cars, pancake it when it's junked, cut it into pieces, they melt it, and they make rebar out of it. Imagine the process of all those electricians working on the equipment that makes the system work. So imagine if you don't lock and tag and that piece of equipment energized while you were working on it. As a non-electrician, as a mechanical guy, I'm not going to talk too much about it because you guys probably heard a lot about it by now, but the rule is you always lock tag, work on the things de-energized, unless you have to, you have no other reason, then you work on thing energized, and if you work on thing energized, then you have to have the PPE, the proper protective gear. And I'm not going to tell you guys if you don't follow that one, it's a law as a project manager. And housekeeping, and I know I teach this for electricians guys all the time, and housekeeping for us as a project manager, because people can trip on things. I mean, it's really a good idea. A lot of people brag when they come to your house to do a service. The first thing you do, they work on things and immediately clean and make things neat and nice. If it's not because of hazard, it's also because of business. If you're sloppy and you come to my work and working on my apartment or whatever, I'm not going to hire you next time. So housekeeping, lock and tag, and if you're not in it because you believe in safety of people, you have to be in it because of the law. You can be sued. The code used this term, qualified person. This is one of the most important terms that you guys can see in the NEC code book. It's called qualified person. And in 2011, Ashley, if you terminate a medium voltage, you have to be a qualified person. A lot of terms in the NEC code, as you walk through, guys, it says a qualified person must do this. A qualified person must do that. For example, locking and tagging this connect here in the off position. When I lock it and tag it, you have to be a qualified person to lock and tag. Qualified in what? In that particular piece of equipment. Lock and tag. If you're working on energized equipment, you have to be a qualified person. If you're a master electrician, are you a qualified person? Are you? Are you? Well, that's what a lot of people think. Let me just read the definition for you guys. Here's what the code defines a qualified person. Who has skills and knowledge. That's easy. You guys can watch Ch1&2's YouTube, and you've got probably a lot of skills and knowledge. Come here. Related to the construction and operation of the equipment. If I'm installing a switchgear in a nuclear plant, do I know the construction, the skills, and the knowledge of installing a switchgear in a nuclear plant? And what happens if you have an accident in a nuclear plant? No. So I'm not qualified, even as a master. Operation of and has, so up to this one, no problem. Read a book or come to one of my classes, you're qualified for this one. The second thing, safety, specific, look at the specific safety training on the hazard involved. And just the last sentence, guys, right here, will disqualify a lot of people. And I'm going to give you an example. For example, if you've never worked, have you worked on a DC arc? Do you know what a DC? Have you taken a training on avoiding an arc that's coming from a DC? No, you're not qualified. Even if I have a master electrician. So obviously, if you have master or journeyman, you are closer to being qualified than other people, but that doesn't mean you're qualified. Qualified, you have, if you're working on one piece of equipment, you have to know every UPS. I've never installed a UPS system. I designed it, but never installed one. I'm not qualified to install one unless I receive training on how to install a UPS system. The same thing goes for you. Wind turbines. I've never installed a wind turbine. I'm not qualified until I receive training on the wind turbine, how to install it, as well as the hazard. What happens if you have an explosion in that wind turbine? And to recognize and avoid the hazard. Anyway, so this is one of the most important things, guys. I can't emphasize the word qualified person. Qualified person. Any questions? So would a registered engineer be qualified? Maybe. Would a master electrician be qualified? Maybe. Depends upon the type of installation and the situation and the training, the safety training needed. Yes, sir.
UPS?
Uninterruptible power supply. So if you lose the power, you wouldn't even know if you lost the power. We're going to do a lot of them in the commercials coming, but yeah, it has a bank of batteries and take the DC into AC, dump it across the light, you lose the power and you have no idea that you lost even the power. So, sorry, I used the terminology. Any question, guys? Any question about this? Exclude this one, should be 2000. The same thing, guys, in 2011. The code 2011. The same information. PPE, guys, this is personal protective equipment. I know we teach you guys as electricians. Karen will put her PPE in front of you, and there's different categories all the way to category 4. It depends how much heat that PPE can handle from this big ball of fire that's chasing you. That's really the whole idea of having a PPE. Is I'm working in a 4,000 amp switchgear, and guess what? There's a big explosion happening because my friend or I dropped a piece of equipment, a piece of a tool right into the switchgear, and I arced. Big ball of fire coming out of you. If you have the right PPE, guess what? Your face is going to stay as is. You're not going to lose your eyes. And the worst that could happen is that pressure might push you, and you might have to go, you survive. You're not going to die. You're not going to burn your face or lose your eyes or burn your skin. But of course, you're going to be pushed back and maybe hit something and hurt yourself a little bit, but at least you survive. PPE does not guarantee that you're not going to be hurt. Because if you have a big explosion in front of you, guess what? You have big ball of fire coming out of you. If you have the PPE, it will protect you. But what happened with the pressure? It's like an explosion, guys. A huge pressure is going to push you away. This might push you hard enough to hit the wall and hurt you a little bit. But your chances of surviving is much higher. Put it this way. Okay, so always, guys, if you're working on electrical equipment, you have it. OSHA, of course, states that. Regulates it in our state. There's Minnesota OSHA and there's the Fed OSHA. You will be penalized if an electrical inspector or anybody or an OSHA inspector walk in and you're working on a switchgear, guys, and the switchgear is hot and you're not wearing the right PPE. Penalized. So a lot of contractors, if you don't want to follow it because it's safety, you have to follow it because it's a law. And God forbid you get hurt and you don't have the PPE and your employer is not providing you with the employer have to provide you with the right PPE, then the employer will be sued. I always say, guys, I have the students over the past, as an electrician, guys, you don't want to put jewelries and all this stuff as you go work as an electrician. All your designers, no problem, but make sure you keep all your jewelries and all this stuff away. So the last thing you want to do is you drop a ring or something right into a hot panel and it's short. When you short, it arc. If you arc, big ball of fire. That's what an arc is. Big ball of fire chasing you. If you don't have the right protection, it's going to burn your face at least. Any question, guys, about this? Like a few things. Rubber gloves, I'm sure Gary talked about you guys. Insulation shoes is part of the PPE. Face shield, safety glasses. These are part of the stuff we teach. We teach you over and over, but be aware, you're not supposed to wear PPE yourself. You're not an electrician, otherwise I go deeper into that. But be aware that your electrician who are working for you, Chris, if they're working energized, they have to have the proper PPE. Any question, guys? Really for project managers. If you're a designer, as I say, that Ch1&2, you'd never work, you don't go to the field, you don't manage crews. That's FYI only. Arc blast. Arc flash, arc blast again. I'm working, guys, inside the panel. Anybody, do you guys know how to wire? How many of you guys wired with us? Everybody else know how to wire, right? So you're opening a 200 amp panel, adding a 40 amp 240 pole from point A to point B. We've done it many times, right? And you're plugging it, and accidentally you drop the screwdriver right into that panel. It could happen. We're human beings. So you take one phase and you arc it to the frame of the panel. Now you got big ball of fire. If it's a 200 amp 240 120, piece of cake will be tiny little ball of fire. If you're just having a glasses, dressed up like me with the protective glasses, guarantee you're good. Now if that was a 200 amp 480 277, very close to the transformer, the amount of arc and the amount of short circuit is huge. So that big ball of fire could burn your face. Yeah, your eyes are protected, but all your face here could be burned. So keep in mind, guys, about this. And look at the temperature that you can get out of that baby. And the whole idea, guys, is always, the rule is, Ashley, when you become a project manager, the rule is work the energized unless you have a real reason to work on energized equipment. Because if you ever seen a category 4 piece of PPE, protective gear, your productivity, Chris, I don't know about you, if you put it on you, your productivity is cut by down to 1/4. You imagine in the middle of the summer when it's hot and you work on a piece of equipment with that shield and you're trying to be productive. Your productivity is 25% of what it should be if you're dressed up like this. Just you can't move in it. So you're going to limit this dress up into only if you have to, only when you need to. Most of the time we work on things energized. Actually, 99% of construction work, 99% is the energized. You pull things, wearing your shorts, whatever, and working on things energized. A couple of things, guys, about arc flash. Life-threatening situations. A couple of things. Here's what I want to say: the four injuries that comes from electrical shock. Electrical shocks. I got a few of them at 220, Chris. One I would never forget. How many? You guys all seen a socket, right? An electrical socket. See that lever right at the bottom of the socket? Common mistake. If you go to one of these sockets, troubleshooting, you go to a socket and they tell you the light is not working, and you put a new. The first thing, always change the bulb. You put a bulb. The bulb is working. It's good, but it's not working. Mistake number one, or next step, is to go to that little lever in the socket. Usually overwork, guys, it will be pushed deeper into, and it can't reach the bottom of the light because you get the hot from here and the neutral from the other side, and now that's how your light goes on. Anyway, so I was working on it and I knew, but I thought I turned the switch off at the time. I thought I turned it off, and I didn't have a screwdriver at the time, and I went and stuck my finger right in and tried to pull that little lever up. Got zapped by 220. The voltage there, that was in Israel, 220, they burned everything at 220. It's like 120. So you get a little bit shock. Hopefully, if you can let go, that's okay. That's where the shock is. The problem, guys, is not the shock as much as the electrocution. The problem that happens is, when you grab a grounded object, piece of panel, if I put my hand right into this panel and I grab a hot object like this, now I act as a motor, literally as a lamp. That's where electrocution happens. You can't let go, and the current keeps cooking you, going back and keeps circulating into your body, and you keep being cooked from the inside, and the circuit breaker thinks that you are a sump pump or a refrigerator being fed, so we didn't wake up. So that's basically where the electrocution is. Higher than the shock. Burns and falls. Burns, guys, is arc blast is a big deal, Phil. If you ever go into remodeling jobs, be very careful. When the electricians open, I've been in it many times, guys. You open a 2000 amp switchboard, make sure you move away at least 10 feet behind him or away from that one, because that big ball of fire, they should be dressed up when they work it. If not, and you're the project manager, you have to remind them that you have to put the PPE when they open these panels. So the burns, again, big ball of fire from the arc, guys, comes and right in front of you. If you go to YouTube and type arc flash, you'll see a lot, tons and tons and tons of pictures and burns and all this good stuff. So you arc line to line or line to ground, big ball of fire comes out of that, right, because of the arc. With this big ball of fire, guys, there's a pressure, right, and there's a huge sound and a big light. So they always say there's a heat that can burn you. There's a huge light that could make you blind because it's so bright. There's also a big explosion that make your ear, you can't hear, deafens you. And if that's not enough, think about that. If that's not enough, there's a pressure that can push you off the ladder, and yup, you survived the burn and everything else, but you fell off the ladder and you broke your neck and you died. So give you an idea how big of an arc blast is. And I'm not trying to scare people, guys. I get scared personally if I go higher than 400 amp. You go higher than 400 amp, really working hot. I personally get scared. I mean, if it's working hot, but up to we're doing recession, right? 100 amp, 200 amp, not a big deal. Just glasses, dress up like I'm doing, you're good for the most part. Any question, guys, about the fall? What's the fall? Because there's pressure pushing you off the ladder. So you're a project manager, you're an electrician working there. Be careful. If they're working energized, maybe you should, maybe be aware of the fall. So don't make them work on a transformer, the top, and standing on the top of the ladder, which is illegal anyway, and working on it. So yeah, there's an arc flash. They're dressed up with PPE, but the pressure pushed them off the ladder and they broke their neck and they died. So a few things that can get you there, guys. If you see something, I was told many times, guys, if you see somebody getting electrocuted, what would you do? Other than getting the heck out of there. If you want to be a hero, what would you do? Somebody see Chad grabbing on that one and shaking. What would you do the first thing? Get out of there? 2x4, thank you. That's especially in the construction, guys. You have to hit them with an object, not hit them in their head and die. Be careful, you know. Or with that 2x4 so hard in the heart and have a heart attack too. You survive the electrocution, but you got a heart attack from the 2x4 or in the head. So I've been told many times is if you have a dry piece of insulation, mainly 2x4, you push them slightly with, you know, wherever the electrocution, try to pull them away. And then the next step, I guess, is to go de-energize the circuit. If you know where the circuit is. Now, if I'm electrocuted here, would you guys know where the circuit is? Most likely it's one of these circuits there. Start turning them off, hopefully. There's no main in this panel. So you're going to start turning them off. So de-energize, push the people away. Don't grab on them. That's tip number one. Don't grab them. A couple of weeks ago, guys, there was here in the cities, one of the transmission line fell off a store. Anybody remember that story? A transmission line. That's high voltage. Fell on the store, and a guy from the store, maintenance guy, went there to remove that, and they got electrocuted. I don't think they survived, but they got a big shock. So going in a high voltage, a whole different. Of course, you're going to call 911 and CPR if you know how to, and or do whatever you can do to get the CPR. And timing, as they always say, is everything, guys. Timing is everything. A lot of good contractors, guys, they give a CPR training and OSHA training for all the project managers, just in case you have an electrician and you have to go in this situation. With arc flash, guys, arc flash, there is insulated equipment and non-insulated equipment, Zach. And you guys, when you work with us, insulated equipment, they have to be voltage insulated. So if it's 600 volt insulated screwdriver, it has to be a 600 volt, meaning if it's to get electrocuted and you're grabbing on it right here, it can handle a 600 volt. Now, can I use it on a higher than 600 volt? No. So be aware when you're working hot, your equipment has to be rated for voltage insulation rated. Not like most of what you buy from Menards. These are comfort grip. They're just really nice to work with them. It's nice, even though they give you some protection, but they're not rated to handle voltage. So pay attention to that. If you're doing meters, that's probably where you guys they send you Michelle Erickson to, they want to remodel, for example, the Hennepin County Government Center. They want to add to it, and they want to add. I have been to do some of these projects, guys. They want to add a panel, and they have no idea. Can they add a panel to this switch gear? They want to have an idea what's the actual load on them, so that you go there and you put meters so you can measure the amps at certain times. So be aware that the meters that you have to have, this one and obviously the high fault current, because if you short with your meter, guys, and your meter is not rated for this short, it could explode in your face, burn your hands, burn your face. So that's always category a higher fault that can handle higher fault instead of the lower fault meters. Any question, guys? Any question? Especially arc flash, especially the arc flash. Training, you guys not electrician, but it's great as a project manager to get some OSHA training, guys. Know what to do, what not to do, what your electrician can do and what they can't do. There's a lot of information you can find in these areas. We do them for electrician. I don't emphasize too much about them for the designers. Free seminars, tons and tons and tons of information. You can read that. Safety, you can't compromise safety. Don't toss around. A lot of, and I say that when a lot of you guys, the people who don't know how to wire or haven't wired, they usually are more careful than the ones who wire more often, because we take it for granted. So don't take a chance. I always say don't take a chance. I personally, from my short experience, I get nervous when I'm working on things three-phase, the 480, any voltage, 480, 277, any amp, three-phase. That's really, when you get into a panel like this, be very careful. Don't force around. Put your right PPE, put your equipment. Lower amps or lower voltages, your chances of survivability is higher. Okay. Any question guys about the safety? So why should you know about the safety? Because you're going to be the project manager one day, and you would hopefully, if you know what the arc blast, you see one of your electricians opening a 2000 amp switchgear without the PPE. The first thing you see, get out of there and go put your PPE, because I'm liable for your safety. So that's really the most important things about this safety. Licensing and permits in the state of Minnesota and in a lot of states, guys, as you know, you have to pull a permit. Anybody knows, how do we pull a permit in Minnesota? Do we need a permit for everything? Anybody has any idea? Okay, in Minnesota, you have to pull a permit for everything except minor electrical work. If you go to the laws and rules of the state of Minnesota, guys, it's called laws and rules of the state of Minnesota. It will tell you have to pull a permit for every electrical work except minor work. And the minor work is defined as replacing defective equipment. For example, see that I go change the lamp over there, defective lamp with new lamps, I don't need a permit for that one. The cover of this, the cover or the device over here, replacing the cover or the device, defective equipment, you don't need a permit for that one. Pulling a 20 amp circuit from this panel to the other end, that's not defective equipment. You need a permit for it. So only minor work, and they define the minor work as replacing defective equipment. No stretching circuits, no extending circuits, you need a permit. In Minnesota, an owner of a house that homestead that house can pull a permit. So you have a house, you have 3 homes, and you only homestead one, you can only work on that one that you homestead, my understanding. You own an apartment, and you're not living in it, you have to hire, you can't pull your own permit. So you pull a permit if you're an owner of a house that you're living in, and other than that, you have to pull a permit for every work that's not minor work. That's the state of Minnesota. And again, that's in terms of permits. And if you guys go to the Department of Labor and Industry, later on as we go to the commercial, I'll take you there. There's a lot of permits now. We can, in Minnesota, we can pull our permits online, and really nice way pulling permits, and there's the fees and tons of other things. So that's a permit. Questions about the permit in the state of Minnesota? For the most part, guys, almost all other states are the same for the most part. We're one of the strictest in terms of permitting and in terms of licensure in the nation. Minnesota is one of the most strict in the nation. Licensure, just a quick reminder, to work in electrical, to do electrical work in the state of Minnesota, and I mentioned that you have to be licensed, bonded, and insured. Licensed as a business and also licensed as an individual or a higher individuals who are licensed. You have to have a journeyman license or a master license to work on electrical equipment. And you can supervise no more than 2 gophers or apprentices. Only 2 people. If I need a third one, what do I need to do from a project management point of view? I need another German. Now, Phil, if you do, I think the ratio sometimes the IBW they use is 1:1, 1 journeyman. Are they doing it? A lot of companies, guys, especially IBW, they push 1:1 ratio. But the law of the land is the state law. It says 1:2. So CA Electric that I work for, I'm a master electrician. I'm going to wire a couple of things. I grab 2 of you guys as my helpers. I can't grab a third one legally. Only 2. It depends on the size and the complexity of the job. Yeah. If the size is too complicated, obviously only journeymen can work on it. Any question, guys, about the permits and the licensure, at least in the state of Minnesota? Most states are the same. We have reciprocity between us and many states, guys. I don't know if you know that. At least 8 states on 2 levels. One level is a journeyman level and also a master level. So North and South Dakota, if you get, I believe you get a master or journeyman from there, you can do paperwork here and you become a journeyman or master in Minnesota. And they're working on a lot of reciprocity between us and other states. Okay, plans and specifications. For plans and specification, you guys know plans and specification more than anybody else. Here's my plans for the house. The specification is, everybody knows what the plan says, basically a blueprint with a lot of symbols on it to represent light receptacles and all and circuits. And specification is a thick documentation, guys, of everything electrical you install. For example, you see that lighting fixture here? That lighting fixture, we need every single thing about the thickness of the steel even that goes into that lighting fixture. I'll give you guys a bunch of specification later on to use. This is what I want to highlight. If there's a difference between the plans and the specification always rules. For example, if I say the minimum conductor size in my specification number 12, and I show a number 14 on my plans, and the installer wants to put number 14, I say, no, my specification says number 12. Then the specification take over the plans. You would hope, Phil, they wouldn't do that. You will review your plans and you put everything as number 12. But if there's any conflict, specification rules. Specification rules. Any question, guys? Blueprints, you look at them, specification, basically documentation of everything mechanical and physical that you can use to describe your project. Symbols, ANSI symbols, guys, will walk you through. If you look at, there's a bunch of symbols that we use in this book. I gave you a bunch of symbols. Phil, you shared some of your symbols with us. We put them in the network. Symbols is, instead of, every time I want an outlet here, I write outlet or receptacle right on the plans. They have a symbol that they show that every one of us look at the symbol and say, oh yeah, they mean this one. So you guys are designers, that's what we do. ANSI has a standard. I have the standard for them. If anybody wants them, I can give you the ANSI standards as a PDF file of all the actual, how every symbol should look like. Here's my symbol of my receptacle, whatever, all these symbols, what they mean. When it comes to the symbols, guys, every engineering firms almost have their own set of specification. Engineers, they think they're smart, which they are. So they have, every firm that I work for, they have their set of specification. I would say 80% of the time, actually, they're the same, but they tweak it slightly different. Or you can follow ANSI's specification. Notification. So you have your symbol, guys, and you have a symbol of a receptacle right here, that you have a note right here next to it. Note number 1, and note number 1, as one of yours notation, it says install 72 inches above finished floor. So what's a notification? It gives more details about this. So this is a symbol of receptacle, right? Duplex like this, and the note right here, it will say, when I write under my notes, it says receptacle to be installed or shall be installed 72 inches above, not feet, 72 inches above finished floor. So it seems they want them high up there for a plasma TV and residential or whatever. Or you put a notification and says receptacle shall be GFCI weatherproof in use cover. These are right now in residential must. GFCI weatherproof in use cover. And you put a note next to it to specify that. Okay, the NEC code book, guys. Taking too much of. Let me just finish this and I'll give you a break, I promise. The NEC code book is what we're going to be designing based on. So these are, at the end, they talk about code of organization. NEC code book, I promise you, as you go through, guys, as NFPA is the ones who write the NEC code book. I don't know if I told you, Chris, I collect the NEC code books. I have them all the way until the 40s. I'll bring my collection. Anybody ever seen my collection? I have a set until the 40s, all of them. Don't ask me why. But and I'll show you as we go through, guys, the first ever adopted National Electrical Code in the US in 1897. I have a copy of it. I'm not special. Any one of you guys can get a copy for close to $83 from NFPA library. You can order that copy, a PDF copy. Really cool, 56 pages. Imagine reading the Electrical Code 1897. Anybody was around at that time? So that's an NEC code book. So I promise you guys, we'll go a lot on this book as we go through. Um, IAEI, it's a great organization to attend to. I don't know how many of you have heard of them before. Anybody have heard of them? International Association of Electrical Inspectors. They put really good presentation, good books that the non-profit organization, obviously, good books to explain the industry. I'm not going to talk about the definitions in Article 100, guys, but as we go through, there is close the IBW always and a lot of other entities, they give 100 definitions must know. Did you guys see them when we were with us? A 100 definitions must know in the NEC code book. As we go through, and IBW put them and other entities must know 100 definitions in the NEC code book without opening the book. So I'll highlight a few of these guys as we go through. Grounded conductor. A lot of you probably guys have heard of them. Grounded conductor, grounding conductor, bonded, arc flash. What's an arc flash is? So these are very important things we can go over it. In our state, 2011 is what we're going to be using for this project. It's adopted in Minnesota as of August 8, up to my knowledge. So NFPA published by 73, that the safety. 73, as I said, if you're a project manager, you might have to do some OSHA training on this baby. Only if you're a project manager. We talk about definitions. This is another definition must know, guys. So we talked about ANSI. We'll talk about ANSI in a second. But let me talk about this, guys. 110.3b, listed or labeled. Equipment must be listed or labeled. So if I go to, there's a lot of, I can talk forever about this one, but there's a lot of stuff, guys. Can you create your own fixture? Can you create a fixture? The creative people, the people with a creative mind, can you create a lighting fixture? You can. The only thing, it has to be listed and labeled. You have to submit it to UL to get tested. So if there's a short circuit, it's not going to burn the house. So listing and labeled, and equipment that's listed and labeled must be installed based on their listing and labeling. For example, can I put this one, fill that fixture right here outside in the parking lot? It's listed and labeled. Can I put it in a parking lot? It's not listed, shared, and labeled for an outdoor wet location. Duh. So that's the whole thing about listed and labeled. Very, very important. You guys as engineers, you'll face this one all the time. People try to put equipment that's cheap, especially equipment cheap, bought from different countries. So you're always going to be looking at listed and labeled. Is the equipment listed and labeled and is it installed based on listing and labeling? A couple of things, guys, about the metric system, and in the NEC code book, you can do anybody ever did a calculation based on the metric system? The meter? You can do calculation based on meter or foot. Both of them are compliance with the NEC code book, no problem. The one that I want to mention, guys, this one is one of the most important things. National Recognized Testing Laboratory, NRTL. Take this. I make a switch gear in my basement, and my switch gear is the best switch gear because I made it, right? And nobody will say bad things about their work, their product. So how can I verify that this switch gear is actually can handle 4,000 amp like I say? The Smarter Than Ch1&2 came up with this called National Electrical Testing Laboratory. UL is notoriously famous. So Chris, I will hire your company as a third party to verify that my switch gear that I made is actually capable of carrying 4,000 amp continuously and capable of interrupting a 65,000 amp short circuit, three-phase. So what is the National Recognized Testing Laboratory? National Recognized, of course, by National Recognized, they established a cloud of respect and qualification, and they test other equipments and label them. NEMA is one of them. ANSI is another. UL is a third one. So here's one, guys. This ANSI, the American National Standard, works with when it becomes a U.S. standard, works with Underwriter UL. So every switch gear that you put in your building, it has to have a label. If it doesn't have a UL label in it, as an engineer, I'm not going to accept this equipment. We get this one, not a lot, but sometimes you get it, guys, where your equipment, a fixture is coming from China and it doesn't have any UL listing on it. So how are we going to install it in your product, in your project? So this is called third-party verification. I do a really great job, but I need a third-party verification. You can't just depend on my Depends upon your political opinion, I guess, on the industry. So you need a third party verification. What they do, the third party verification, Phil, is they take a 4,000 amp switchgear, put it right here, and pump 4,000 amp on it, and let it sit for a while and see is it going to explode. And then they test, basically test, they blow up things. And then they put 65,000 amp in the circuit breaker. Say, is it going to trip? Let's see how fast it will trip. And is it going to explode in the process of tripping? So they test it. If it meets the specification, they give it a label, stamp your label on it, and they list it as suitable for this application. Your listing. And they always test them for safety. A bunch of others, guys, they test. UL is notorious, the famous. The Canadian also, NEMA, Intertech. So these are all, you see all these labels, NEMA 1, NEMA 2, NEMA 3, enclosures, NEMA 1 magnetic starter. You see a NEMA 1, ylse, they're good. So plus UL listing. So these are third-party verification that they can get you. They can, when you see the label on the equipment, guys, you're guaranteed that you have a good piece of equipment that you install in the US. Internationally, they have different standards that they use. Any question, guys? Any question? So that's a quick. Here's my advice for all of you guys about this book. Read it one time in your life. There's a good information to know. Some of it not directly related to what we do. But if you're a project manager, every single thing, if you want to be a project manager one day, the more you know about this, the better you will be. If you're a designer, some of this stuff might not relate to you. Okay, let's take a 5 minutes break. Here you go. Okay. So, for chapter 2, they told me that you smoke down here. These sneaky guys. I asked about you, he said. Okay, electrical symbols and outlets. I gave you guys an electrical symbol list. And Rob, do you remember when we loaded all these symbols to our plant? So you guys are familiar with them. What I'm going to do here, this chapter takes these symbols and outlets and explain them a little bit. Here's what we're going to do first. Identify and explain the electrical outlet symbols used in the plans in a single family dwelling. This project has symbols that they're using. I want to touch over them or touch them. Outlet boxes, luminaires, and switches. So basically, we're going to talk about the symbols that they're using, guys. Mounting. The second thing I'm going to go over other than symbols is mounting, methods of mounting for various equipment. And I'm sure I can look at Nick and they say, Chad, who cares? I'm a designer at Mishad. I care less about mounting. If you're a project manager, an estimator, which this program is supposed to turn you to, and you will do takeoff on a project, guess what you need to know? You need to know a few things about the hardware. Part of the hardware is mounting devices. So big deal for project managers. If you're a drafter and designer, guys, at an engineering firm, you never will be, nobody will ever ask you about the hardware. And you're not expected to know all the hardware. Receptacles in boxes, the position of these, and for remodeling work, what you do. Maximum number of conductors. Box fill. Did you guys do box fill calculation with Gary? I'm going to do one example calculation box fill and then I'm going to move on. Not today, but I will be doing one example, right? Because you guys killed the goat or sheep. But I'm going to do pull box calculation, which is a slightly different. So box, maximum conductors in one box. This is another concept. If you highlight it, fire resistance of walls. If this is a fire-rated wall and I need to penetrate with my conduit from this side to the other side, what do you think I need to do for this fire-rated wall? I need to maintain the integrity of the fire-rated wall. That's a big deal for electrical designers and engineers alike. Okay, so I'm going to switch from the PowerPoint presentation into a couple of slides here, pictures basically. Let's go right here. Okay, so this is what you guys are going to be doing with Chad, right? Here's a room, and I need you to put your receptacles in the room and circuit them. That's what symbols are, right? I have 1, 2, 3 receptacles in one room, And this is exactly what you guys are going to be doing with me. And what you need to do, I want you to circuit them. So we're going to grab circuit, one, circuit, right? And from here, I'm going to go with a home run. And this is going to be circuit number 1 from apartment panel -1. Oh. Did you do that to me? Before my... Does that make sense, guys, for circuiting? Circuit number 1 from apartment panel -1. I'm losing my battery here. All right, I'll plug in yourself. Chad, we're good here. Any question, guys, about this? Here's your symbols that you're throwing, right? Circuit them. Then I decided to use a lighting panel, guys. I have a fixture from right in here. I'm going to be circuit number 2 from apartment panel -2. Here's what laying out and circuiting. So next week, starting on Wednesday, you guys will be throwing all these receptacles on the walls. You will be spaghetti them, right? See what I mean by spaghetti? Connect them together. I want you to do spaghetti this project, guys. Only this project. Next project and the project after, we're not going to do spaghetti. Just this project. And then lay out a circuit. So any question about circuiting? See how we circuit them from the wall? Now, how far from here to here? Anybody can tell me, but based on the code, if this is a livable room in a residential, how far should it be? 6. That's the 6-foot rule. And from here all the way up to here, anybody can, to meet the code, how far this should be? 6/12. That's it. So this is your 12 here, feet. And from here to here, all the way up, how far this should be? No more than 6 feet. And from here, no more than 6 feet, and from here, no more than 6 feet, right? Everybody knows that? That rule 6/12? Done. With all your receptacles. Any question, guys, about that? Any question? Any question about circuiting that one? So that's basically what we're doing with the symbols and circuits. That's what you guys are going to be doing. Let's move down into, I'll show you the symbols that we're going to be using. If you're a project manager, now some of you will say, who cares, Chad? If you're a project manager, we call this whole deal here, we call this whole deal, it's called an assembly. When you take an assembly, guys, you take a box, a cover, a mud ring with a box, as well as a device. We're not showing the device, but there will be a device right in here. That you put it. This is an assembly. Who cares? We're not going to install them. I'm not training you to. I hope you know how to wire it, because you guys, if you don't know how to wire, make sure you come with your friend Chad to one of our labs so we can show you a few wiring. If you don't know how to wire, guys, you're not supposed to wire when you graduate, but it will be really a tough for you to be a good designer or an estimator. If you don't know how things are put together. I hope by the time when you come to me in the second year, everybody knows at least the basic of wiring. You might not be able to wire a UPS, but you know how to wire a power circuit, a lighting circuit, 3-way switch. If you don't, we can emphasize it more. So, as we all know, guys, the white is always your neutral. The black is always your hot in the US, and the bare conductor is your ground. This is a circuit coming to an outlet. The code says you need to project 3 inches. See that 6 inches right here? You don't need to know more of these details really for the installers. From the point the wire enter the box to the point you terminate it, you need 6 inches. And Phil, you can argue with me, these 6 inches for what? For terminating the wires onto the receptacle. So that's a big deal for us, the 6 inches. Any question, guys? Any question about that one? Who cares about this? An assembly. 99% of the wiring method. By the way, how many wiring methods we have in the US based on the code? Wire methods. Everybody knows what a wiring method, chapter 3, wiring methods, that's what we're going to be studying. There is close to 50 plus wiring methods, meaning, see that outlet right here? I can wire it in close to, I'm exaggerating a little bit with outlet, 50 ways. 50 ways based on the conduit, the wire, the cable, different type of cables, different type of conduits, different type of flexible conduit versus rigid conduit, and so forth. Or surface mounted raceways, like you can see here, mold and so forth. Any question guys about this assembly? When we do takeoff fail, that's what you assembly going to be taking off with me later on as we go through this. Now, based on the code, the NEC code book, you need every outlet receptacle have to have a hot, of course they have to have hot, neutral, of course, otherwise it wouldn't work, and a grounding conductor. A grounding conductor. So moving into, so these are an outlet. In the code defines an outlet, guys. You go to the code, the definition, an outlet is a location we can utilize power. An outlet is a location where you can utilize power, plug in things. Also, an outlet is a location where you can utilize power as a lighting fixture. So there are two types of outlet. There is power outlet or receptacle outlet. These you're looking at them right here. And there's light outlet, and you're utilizing power at a lighting outlet by plugging in a fixture. So please be aware that this is called an outlet, and an outlet could be power and lighting, or lighting. Okay, a couple of things about lighting fixtures and hardware that you guys can do. I can't emphasize, when it comes to residential, guys, 90% of the wiring method that we use, 90% of the time, you're going to be using Romex cable, NM cable, so you need to know everything about that. And you're going to be using non-metallic boxes, 90% of the time. There's 10% of the time you will be using metallic boxes and EMT or PVC conduit. That's only 10% of the time, at least in Minnesota. I heard in Chicago they use EMT for wiring everything. Other states you might, like in the city of Chicago, you wire with EMT, a house. So a couple of wiring methods. Let me go directly. Symbols, a couple of symbols, guys, you're familiar with this one. Here, if I were you guys, I'm reading this book and this chapter. Here's what you need to do. And I know you have seen this before, some of you. If you haven't seen this, please review them carefully. Number one, every time when you graduate from us, every time you see this symbol, you should be immediately jumping on me, chat. Oh yeah, this is a duplicate receptacle. You don't have to memorize it because it's always part of the legend, but you need to be aware as a designer that you are looking at a symbol like this. This is a duplex receptacle. That's that one on the wall that you're looking at. If you see an S like this, it's always a switch. An S, 99% of the time you see an S, it's a switch. The number next to it indicates it's what? It's a three-way switch. Everybody knows what a three-way switch and four-way switch and single-way switch is? Three-way switch, right? We'll show the wiring in a second. If you're looking at a fixture like this, the symbol, guys, ceiling lighting outlet, an outlet in the ceiling. You don't need to memorize this, but as you go through this book, these are the symbols that they're using, guys, to modify it or to design it. Moving into, here you go. You guys have this in your in page 32. These are, no, not 32, the page 31. These are all the lighting outlets that we're using. The lighting outlet that we're using in this project. Let me see if I can get them up a little bit here. There you go. I'm not going to go over all of them, guys. You guys have them in your book, right, everybody? So for outlets, we're using, they're showing different symbols for the wall and the ceiling. So surface mounted incandescent light. Here's the outlets that you can pick any one of these three in either wall or ceiling. I don't want you guys to memorize this. Here's what you need to know. I already gave you symbols that we want to be using for our project. I want you guys to use the symbols, but if you, and I gave you a legend for the symbols, right? The symbol list that I gave you. So we're going to be using this for our project. And the legend will, this is what you're looking as a legend. Every time you see one of these, it's actually a surface mounted incandescent in the ceiling or on the wall if it looks like this. Lamp holder with pull switch, and different type of fixtures. So what if I were you guys, just familiarize yourself with the symbols that they use, and that's as far as you can go. If you couldn't find, Phil, I know you grabbed some of your stuff and we put them in the network. If you couldn't find a symbol that you need, which I doubt that you will for our project, it's a good guide here to lead you towards how to find this thing. Recessed incandescent light, surface mounted, recessed fluorescent, surface or pendant light in a row, all the way to surface or pendant exit light, recessed ceiling exit light, blanked outlet, junction boxes. So, any question, guys, about these symbols? No memorization. This is just FYI only. So when you look at a symbol like this, you're going to know that this is based on this legend. It's a surface or pendant exit in the ceiling. Now, the symbol list that I gave you might be slightly different, guys. So you're going to follow the symbol list that we gave you for this project. Any question, guys, about that? Any question about that? So the book, and I really like the way they did their legend. They specify all the fixtures as well as the ceiling or wall, and they give all these symbols that you can use in ceiling or wall. The nice thing about what I gave you guys is you have these in CAD as blocks. Any question, my friends? So these are your fixtures that you can use. Moving into the second one, receptacles. If you guys look at the receptacles, here's my receptacles that I can use. You guys have this, right? An outlet. If you see this baby here, this will be your single outlet. Notoriously famous. 99% of you guys will be probably using something like this. Duplex receptacle, that baby on the wall. What is this? Quad. This is when it comes to industrial, guys, industrial, commercial. This quad becomes we use a lot of quads in a lot of places. Basically, two of these right into one box. Duplex receptacle outlets, split wired outlet, duplex receptacle, triplex. This is a quad. This is a triplex. 3 of them. This is 3. This is not commonly used, the 3. This is the quad that I'm talking about.
Where would you see that, Chad? I saw the picture of it.
Triplex, yeah. It's 3 on one yoke.
Yeah.
3 receptacles in one yoke. I've never installed it. When I was now granted different life, different location, some wiring method in Israel they use, guys. Every one of these is a tiny little. Every receptacle is actually a device. So what we did is you have a box like this, and you can build this box. We have put one receptacle here, one receptacle, one receptacle, one receptacle. So every one of them, they make it one yoke receptacle. You can build them in a box like this. I've never installed a 3 receptacle yoke. Anybody ever see them? But I'm sure there's a lot of manufacturers that can use them. It's usually a quad. There is a quad, one big quad. So.
Well, it's also impossible to do it safely with a 3 based on the rules about where you place the ground is up or
the ground.
neutral is up.
Yeah, based on where they recommend the ground or the neutral.
Take a look at it. It's impossible.
Yeah, based on where they get. We'll get into the recommendation. Any questions guys about these? Look at that closed dryer. This is a symbol that I'm using for closed dryer. Obviously, this will be a 240 volt system. Exhaust fan, clock outlet, floor outlet. Again, these are symbols that you can use, but I gave you symbols that's very similar to this for our project, guys. Comments, questions? I want to comment about these because these are becoming a very big deal. Weatherproof, GFCI, and weatherproof GFCI, and in-use cover. Every receptacle that you use outside now, guys, in a wet location or a damp location, has to be weatherproof. In-use cover. Everybody knows what in-use cover, the bubble, in-use cover, and of course GFCI. Look at this floor, duplex receptacle outlet, F flush and S surface mounted, so they have their own legend for that one. Please don't memorize them. The question would be on that one is, I would give you a symbol like this, and I say, what does that mean? But I have to give you the legend though. Without giving you the legend, Chris, it will be awful too. But if you are a new designer, which I assume all of you guys are, I would just read through them. That's all I'm asking you guys to do. Questions? Any question about that? Any questions? Another one for switches that they're using for this project, my friends, if you look at them. Oops, that's too much. If you look at they have switch, single switch. Everybody knows what a single switch is, right? Come on here, buddy. Single switch. Double switch, what's double switch, right? You have 2. This is for 240 system. 3-way switch, 4-way switch, door switch, dimmer switch, a glow switch toggle glows in off position. Key switch, you have to have a key to turn the switch on. Low voltage switch, and so forth. So these are all as for switch, and these little indicators next to them, guys, indicate different type of a switch. So if you're using a switch like this, which one would we use, guys? Single switch. So if I'm indicating these on my plan, 1, 2, 3, 4, 5, and you want to show them on the plan 5 of them, right? These are your 1, 2, 3, 4, 5 switches. This is your 5 switches right on the wall. 5 switches right on the wall. They're all single pole 120 or 277 switches. Any question, guys, about the switches? Please review them one time in your life as you go through. I want to indicate one little thing, Phil, here, my friend. This one, I want you to pay attention to it. Low voltage switches. Everything that we're going to do in a commercial project, guys, next it'll be low voltage switches. So when you put your S next quarter, it's going to be LV next to them. And this one also, key operated switch. Key switch with a pilot light, key operated switch. This is coming, guys. Do you guys have you worked in schools and places where they don't want you to tamper with turn the light on and off? Like that hallway is a good, and the stairway in a building like Dunwoody is a good application for a keyed switch. You keyed it on, and nobody else can turn it on or off unless authorized people. So that's a good application for it. So questions about the legend? Questions about the legend? So that's basically what we're going to be doing. And so when you guys have your book, I know you don't have it now. When you have your book and I walk you through this blueprint, they're using this legend. So every time you see, for example, you see an SD here, and if you have no idea what an SD is, it's a door switch. So as you open, like in the closet, you open the closet, what happened to the light in the closet? Anybody has a closet that when you open the closet door, the light will go on? Jam switch, door switch, that's where you can use them. Fridge is a good example. The refrigerator, when you open the fridge, the light goes on, right? This tiny little switch, jam switch there. Okay, questions? Questions about that? Circuits. Now remember, guys, 2 things. Most of this project will be, you're going to have in this project 3 types of loads. You're going to have a lighting load. Remember, we give you all the symbols for lighting loads. Receptacle load. We give you all the symbols for receptacle loads that you can use. And we also have equipment load, like in a fan, all the stuff. You're going to have different equipments. After you lay out your equipments in a building, guys, what do you need to do with them? Circuit them. And that's where the different type of circuits, guys. This is one legend for circuit. And again, you don't have to follow that legend, but it's at least one way. If you look right here, it says hot home run to panel. Number of arrows indicate number of circuits. So how many circuits do I have here based on the arrows? 2. Not every firm use this, guys. Not every firm use that one. So just this is theirs. Of circuit, letters and numbers indicate circuits. Letters and numbers. So A1-2, that's circuit 1 and 2. Full slashes indicate ungrounded hot, the full ones, or switch leg. Circuit conductors half slash indicate grounded neutral conductor. No slashes indicate 1 hot and 1 neutral conductor. 1 hot and 1 neutral conductor. So can anybody read this for me then? Is that a multi-wire circuit based on the description? It's a multi-wire circuit, 2 hots and a neutral. 2 hots and a neutral. Any question, guys? The legend, you can use any legend you want. I gave you guys a legend for a circuit that we do, home run. But this is the home run that they're using. A lot of people use this legend where this is the neutral, this is the hot, and one like this. So this is ground, this is neutral, this is hot. So that's a legend that we used in our project. And this is one home run. And then you put your circuit number 1 panel -1. Circuit 1-1. If I want another circuit, here's another hot. That will be circuit 1, 3. Anybody knows why I picked 1, 3? Multi-wire branch, everybody knows what a multi-wire branch circuit is. Multi-wire branch circuit, you always take two hots from two different poles or phases. So the panel like this, as you move through, you're going to odd, even, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6. You guys know that, right? And the left-hand side, the odd, the even on the right-hand side. So 1, 2, 3, 4, 5, 6. So if you want two hots, you have to take two odds adjacent or two even adjacent. So when I say 1,3, I'm taking the two poles on the left, the first one, and the one right underneath it. These are from hot 1, hot 2, or phase 1, phase 2. That will give you a multi-wire branch circuit. If this is a three-phase circuit, I hate to say it, but if this is a three-phase circuit, here's a three-phase circuit. That will be, anybody can tell me, so 1, 3, what should that be? Coming from 5, 1, 3, 5, right? So to have a multi-wire branch circuit in three-phase, guys, you have to have a 3 numbers adjacent odds or adjacent evens. Any question about this? Any question? We're not using this for our project, guys. Here's what we're using for our project, similar to this as a home run. But Rob, my friend, if you use a different home run, no problem. Go to your symbols that we have, edit that home run that I gave you, and use any home run that makes sense if you have from where you intern or whatever. I'm not stuck with it. As long as you put it in your symbol. Anything you want to do, you have to put it in your symbol list. Cool? So this is just your circuiting, because all what we do, guys, is basically we throw symbols and we circuit them. Branch circuit. Look at the conduit concealed and wiring concealed in construction, in finished areas, exposed in unfinished areas. Look at the conduit. These are my two favorite. If you see the symbols in the ground, this is conduit turning up, conduit turning down, conduit only, switch leg. So all the legend that they're using with this particular fill project. Remember, this is symbols going to a project that they're having. What I like about this book, guys, it walks you through, and me and everybody else, through an already designed project based on somebody's opinion. So it's nice to look at different things. When I was doing design, guys, as an engineer, I always liked to look at other firms' work and see what you can learn from, what's the best practices. So that's one best practice you look at. I'm sure where you work, some of you guys doing interning, where you intern, they have a lot of other best practices that they're using. Questions? Any question, my friends, about the circuiting? More symbols, if you guys look at and again, these are FYI only, really. More symbols, if you guys look at the disconnect switches. Oops, I can't highly. I'm just going to pick a few here, and I'll let you, as we go through, guys. Doorbell, chime. You're going to be doing the chime for me. Here's the doorbell, and there's a chime underneath it. The chime, fans, different fans, you name it. Disconnects. A lot of disconnect symbols, circuit breakers, batteries, and so forth. These are all symbols. And actually, my friend, all these symbols are meaningless unless you have a legend. Unless you have a legend like this that tells me what is this as a buzzer, it doesn't mean anything. Any question, guys? Here's what I want you to use these. Please use the symbols that I gave you. Tau and then if you couldn't find these symbols, use these as a guide. Telephone outlets. We're going to be using low voltage, guys. This is also the low voltage stuff. Most of the electrical symbols is divided into power. When you go to any electrical symbols, you have the power, you have the light, you have the low voltage, and you have the circuiting. And then you have other general stuff. You always start with the power, receptacles, and so forth. Then you go to lights, all light fixtures. Then switches, switches go to light. And then you get into the low voltage, fire alarm, security, phone, data, and so forth. And then you get into the circuiting, the way they circuit it. And then general lights, general symbols that they use. So do me one little favor, please just review them as you go through. And that's all what we're asking for as we go through. Symbols for notes. Remember the notation that we talked about, guys? You can use any of these, like you can put here track light, provide 5 lamp holders. So when you put these notation right next to your equipment, guys, the notation, you have to, notations have to be identified. So if I put note number 1, what is note number 1? Note number 1 says all receptacles shall be at 12 inches on center above finished floor. That's a note. Because I have no idea how far you want to put your receptacles, how high you want to put your receptacles. Any question, guys, about the notation? Notations are really cool. It gives more information about the receptacle. So, for example, I put my receptacle here. Here's my receptacle here. Note number 1. Enter length of the workbench outlet 18 inches on center installed, 48 inches to center from the floor. So that could be that receptacle, description of that particular receptacle, how we're going to install this receptacle and the others. Any question about notation, guys? Any question about notation? When you guys design the project, you come to your friend Chad, and I'm going to be asking you, how do I know that this receptacle is an arc fault circuit interrupter receptacle or protected, right? You guys want to come to me. Everything has to be arc fault circuit interrupters. How do I know? You have nothing on your plans that tells me it's going to be an arc fault circuit interrupter. So that's a good note to say arc fault circuit interrupters. Split wired receptacle outlet, weatherproof, a couple of things. Anybody knows what a split wire? Where you can bring circuit here and circuit here. So here's circuit number 1 and circuit number 3, right? You guys wired them with us? Split circuit. And weatherproof receptacles. In 2008, the code came up with this. We just got sick of, guys, every time we change the receptacle on the outside, you take that receptacle and it falls apart in your hand. Have anybody done that? You thought it's falling apart because of the heat and the cool and all that stuff. They make them from a stronger material right now if they're in a wet or damp location where hopefully they survive, their survivability is higher. So that's what weatherproof. Any question, guys, about that? Symbols that you can put next to them? A couple of things about the hardware, guys. Here's the book, really nice. It goes through and shows you a lot of, here's the symbols that we use for the light. Remember these symbols, we just talked about them. And here's the type, the actual fixture, and here's the hardware that goes with it. I'm sure, let me ask you guys, you did wiring with us, right? Excluding you. Did you guys do wiring? So wired at least a 3-way switch and 4-way switch and a light and the power. So you're familiar a little bit with some of the hardware that we use. So a few hardwares that you can use, the receptacles and so forth. That's what I like about this book, guys. If you're not familiar with the wiring, it's really nice, graphic. This is my favorite when we come to the estimating. When you guys come to estimating, 2-pole. So if you have a single, here's the circuiting, right? Here's your circuit, how you, in the US, we switch the hot or the neutral. In the US, the hot. Other places different. We switch the hot. 2-pole. You can switch 2-pole to feed the light. 3-way switch. See how we wire the 3-way switch, 4-way switch. This is a 2-pole with a pilot light. Have you guys seen that where you turn it on and the light will go on? And you turn it off, a little light at the tip here will go on and off, a pilot light here to indicate that the switch is in the on position, indicating light. So anyway, so these are really nice. You're not wire men and women, guys, but the more wiring you know, the better estimators, project managers, designers you will be, no question asked. So when we start taking off later on, I would say take off this project, and you're going to take off this 3-way switch. And if you don't know for a 3-way switch, my friend, right in here, you're going to have a 14-3. If you don't know how to wire them, how would you know that you need 14-3, not 14-2? So that becomes really handy if you're using cables. Any comments, guys? Any question about that? Comments, questions? A lot of things about wiring, guys. Let's do that one. This is one of the nicest things because, and I know you guys are not electricians, but it's really nice to know that there is a piece of hardware that can take you from one type. This is a combination taking you from an EMT into an AC. How can I go from an EMT? Remember, there's 50 plus wiring methods in the code. How can I'm going with rigid here, and I need to go to PVC. How can I go between rigid and PVC? Is there a piece of hardware that can take me direct from rigid to PVC without going through a box? That's what, if you're a project manager estimator, the more you know about these, the better. For example, I'm going EMT up to this point. I need to go AC. I can do two things here. Two things. I can put a box here, no problem. A J box. You can bring the two together. Or if I know that there is a piece of hardware that can take the two together and tie them, it will save me putting a box. So really, who cares about this? Estimators and project managers. And I don't know about you guys, but I consider myself above average with the hardware, but every time you walk into a place and you look at all the screws and the hardware that goes with it, there's just so much. There's so much. Bus ducts, you don't see how many hardware comes with the bus ducts, putting a bus ducts on the wall. If you haven't installed it, there you have to read directions basically. Switches. One thing in 2011 came. Anybody knows the new change in 2011? Anybody knows what the new major change in 2011? Switch have to have a neutral. Now, as this will change the way we design residential. If these are two switches, here's my hot 1 and hot 2, okay? Let's just say that this hot 1 and hot 2, or let's just, we're going to make this as two switches. I bring, this is my hot, and I have switch number 1, and here's switch number 2. How do you wire it? We bring the hot to this and this, right? Now we took the hots, no problem. I took my hots to there, and then this, no problem, goes to, let's use this. This will go, so that will go to my fixture number 1. I have my neutral here capped. All my grounds are tied together. Here's my ground, and you tie them to the switches, right? To the side of the switch. I have one neutral. Can I use the second guy to identify it now? The second switch? Can I do that? Based on these wiring? Can I take this one as a switch link to the fixture? No. You can't take this one as a switch link to the fixture based on this wiring method. You can't because they can't say it. So in this case, you have to bring this one here and you bring that one, make it identify it as a hot. Anyway, so you make the neutral, re-identify the white as a black, bring the power to the switches, and from there you take the power to the two lights, and you have to have a neutral conductor. Long story short, guys, because of that requirement, you will be required to use a 4 conductor cables now. A lot of applications, 4 conductor cable. So be aware of that one. We used to get away with 2 conductor and 3 conductor cable. A few applications, 4-way and 3-way switches, you might have to use a 4 conductor cable, the raw mix which they make. So I wouldn't do that the way it's done here, but it's at least one way. If you're extending, guys, from a box like this is just again hardware. As you can see, you can't do it this way with rigid because you can't open this box. So you have to extend the box. Can you see how they extended the box and put the conduits right here? Or you can have a flex. This is flex. Why do you think this is right? Because it's a flex. Boxes. One thing, guys, you need to know, and I promise you I'm going to stop talking soon. One thing you need to know about electrical power, you cannot terminate any electrical circuit except in an equipment or a box. You always have to terminate in box or equipment. So here I'm terminating these two together. It has to be a box. And the box have to be accessible. So Phil, if I have a J box above this ceiling, the box have to be accessible. No problem. Move the panel, get up, get to it. If you put the conduit this way, the way they're showing it right now, the box becomes inaccessible or unaccessible. You can't access it. If I do a flex like this, no problem. Because the flex, you can unscrew them and move it up. Anyway, few hardware tricks that you need to know, especially if you're a project manager estimator. A few hardware again, moving to the hardware. 99% of the time, guys, if you're residential, you're using non-metallic. Non-metallic, as you can see, how many gangs is this? Everybody knows the term gang. This is a two gang box. Most of the time, we're going to do a 2-gang. This will be 3-gang, and this will be a 4-gang. So who cares about the gangs? If you're not familiar with it, which you should be, you can put 1 receptacle, 2 receptacle, 1 switch, 2 switch into these 4 gang, right? And you still be okay. So you guys wired a few of this, right? With us, you should wired a few of these. A couple of things, guys, about how many receptacles, 2x4, and the number of conductors you can get into them. 310.14. Is that what 310.14 talks about box fill calculation? I promise you, for the box fill calculation, guys, we'll do one example at least. 310.14. Oh no, 314. Why 310.14? That's 314. 314. This article talks about boxes, guys, box fill calculation and pull boxes. I promise you we'll talk a lot about this one as we go through. But it really comes handy for metallic boxes. Non-metallic boxes, Chris, if you open them, right at the back of them, they stamp them with the number of conductors and or the number of the cubic inches they have in them. So if you have the cubic inches, you do the calculation, which we will do the calculation. At least one example I do, because you guys have done that before. So but one thing I want to mention, again, this is directly coming from the code. So for example, the way we read this one directly from the code, this single gang device box, guys, if I have number 12 conductor, I can put, and this is the depth, I can put 3 conductors number 12. If I go deeper, I can put 4, deeper, continue to be 4, deeper, 5, deeper, 6, and so forth. The deeper, the more deeper and big the deeper the conductor, the more conductors you can fit, the deeper the box. Can you guys see that? They're all 3-2, 3-2, 3-2. The only difference is how deep that conductor is. So, Phil, you get into a place where the inspector is mad at you because you exceeded the box fill, and you are using 3x2 by 1.5. To make him happy, what do? Go deeper. Change it into a deeper box. So get you more conductors. So, and you guys are familiar, we've seen this before, right? You've seen this, so we will use a couple of boxes, and we talked about this one today. If you guys can, most of the time, guys, we put the device against the studs in residential, but suppose you need to put it right between the studs. They have a hardware where you can attach your, or mounting strips, you can attach your boxes to put them right between two studs. So be aware of that to make it fit exactly where you want. Remodeling and fittings. This is very interesting. Anybody install these? Remodeling. For remodeling, they come very handy. You fish the cable, make a box, fill it, and tighten these, and it'll get you. This is mounted in the ceiling. Can I put a fan here? No, fan have to have fan-rated boxes. So keep in mind, these also they use, guys. Have you used them with Gary? Gary loves them too much. So you guys have used them where you remodeling for metallic boxes, right? And you make a hole, put them in. Why are you guys laughing? Do you have an issue?
No, he loves them.
He loves them? He does? Yeah, they come really handy. They come handy. So these can come as hardware. This is where I want to emphasize. Fire rated wall. If this is a fire rated wall, guys, if I make a hole right here, and this is a fire rated wall, I can't make a hole in this wall because that will compromise the integrity of this fire rated wall. 2 options. So what they do, if this is a fire rated wall, guys, you can't put back to back like this. Anybody knows why they don't like? Anybody knows where would be a fire rated wall in residential? Thank you. Garage, attached garage. there is a fire because of, right? Attached garage, you double sheetrock them to make them fire rated wall. Every time you shear double sheetrock, that's a fire rated wall 1 hour. So you can't put back to back like this. If you put them, the idea is your car is sitting right here, like Chad's car, on fire, and put spread here and spread the fire right through these boxes to the other side. You compromise the integrity of fire rated wall. So 2 options. Number 1 is you put them into 2 different stud area like these. So that will be the fire rated wall right here. It's not compromised. And you put them right, one here and one here, right? And if you decided to put them this way, then you have to have some type of putty that you put around it, guys. You have to all these putty that you put around it so it can increase the survivability of the box and reduce the spread of fire. So you have to maintain the integrity of fire rated wall. Always pay attention, even in commercial, even worse in a commercial building. Okay, or look what they did here. They put a divider between them so it can't spread the fire between point A to point B. Almost always in a residential, the garage, attached garage. Pay attention to the attached garage as you install it. Here's what I'm talking about, guys. You can't put them here because you love this location. You can't live without it. So you have to put that putting here to maintain the 1 hour fire rated wall. Any question, guys? I think that's very important. If you're wearing apartments too, they don't like to do. Anybody knows why we don't like to do that in apartments, between 2 apartments? I can listen to my neighbor. Don't want to do that, right? So you usually try, if you have 2 apartments, the wall between the 2 apartments, we try to put devices in 2 different cavities because of voice transmission. Okay, here's fire rated. You make it fire rated, that box. You guys have done that one. We will do one example when we do calculation for box fill. So I promise you we will do that, adding a ring and so forth. Couple of wiring. There's something here. Recommendation. I don't know how many of you guys like. I hate that. According to this book, this is how they recommend the receptacles to be installed. A lot of receptacles here in Minnesota are not installed like this. Again, it's not code, it's recommendation that the grounding is at the top. And the idea, guys, if you drop a sharp object here, you drop it, which conductor you think you're going to cut through? Here. You're going to cut through the ground, so that will be safer. Versus if it was the other way around and you drop a sharp object and the cable plugged in. There's a cable plugged in here. Which one you're going to cut? If it's the other way around, you're going to cut through the hot, so you're going to arc. I don't know. I don't like them this way. Anybody likes them? You like them this way? Yeah. My house is the same thing, and I try to change them. I think we get used to the way they are. And I'm telling you, I mean, I saw wiring in 3 countries. It's always that way. You know, plugged the ground is always at the bottom. So that's maybe I wired in Jerusalem with the ground at the bottom. Different receptacles, but the same concept, the ground at the bottom. So this is recommended. What the rest, guys, are not code violation. The rest are not recommended. So I don't want you to think the way they're showing it. I don't know if we are code violation. They're not code violation. This one, for example, they say an X on it. That's a lot of homes are wired this way. That's just not recommended based on this author. This is recommended. This is not recommended.
Okay, so
Again,
it's just recommended by the author.
Recommended by the author. But look at, see that? Look at this one here. Can you see it? Look at these. Look at all these here. So they're not code. So these are based on this, not recommendation. It's recommendation. I don't see anything. It's not code. It's just recommendation. So don't sweat it too hard. A couple of things, guys. Also, as you install good workman or workwoman like manner, when you put your switches, can you guys see how you put your, either you put it in the tile or off the tile, in the tile or off the tile, but you can't put it. It's not a good idea to put it in proper location. If the inspector see you doing that, he don't like it. You see what I mean? Half in the tile and half out of the tile when you install them. So that's I agree with. Either you put the whole thing in the tile or off the tile. You put it right here or right in here, not halfway in between. Not halfway in between. Okay, back to the location, the orientation of the receptacle. You know that these are only recommendation, right? They're not code. This is opinion. Again, workmanlike manner. All these are workmanlike manner. Workmanlike manner. The code define workman. There's a whole document about workmanlike manner. Can you guys see how they are? Everything is really nice to the bottom versus this is how probably Chad will install them in every direction that God created. If you can, that's great. But I think it's nice if you can do it here. So it's good workmanlike manner, and look at they have to be balanced and all this good stuff. Not code though, workmanlike manner. And actually, we're going to change it into work person-like manner one time. I think somebody has to submit because there's a lot of people, female in the industry now. Okay, a couple of things, couple of hardwares. Really nice. This comes really nice, guys, in commercial, not in residential, where you can put that bracket and mount a lot of stuff on it. Okay, this is table number 1, guys. Please highlight it for me, will you? This one. And I hope you understand that, Rob. I'm going fast through that one because that's a review for a lot of you guys. A lot of you is review. This one is a cable that can get you what counts and what not count when it comes to box fill. What counts and what doesn't count when it comes to a box fill. This is one of the best tables I ever seen, guys, about box fill calculation. So please highlight it for yourself. And when I give you guys an example, so for example, you have a box like this, and I have a conductor coming in, passing through, that count as 1. A conductor that come in, land, terminate, count as 1. All devices count as 2 based on the conductor landing on them. All equipment grounding conductor count as 1 based on the largest. Remember these guys that you did with Gary and with a lot of us? But what I like about this particular table, it's list them. I don't know if you guys have seen a different table, but really nice table to list all of them, summarize them. These are directly from the code, 310.14. I mean 314. One minute. Keep saying 314. Any question? Any question about this table, guys? So please highlight it when we do the example. If you forgot how to do the box fill, I'm going to be referring you to that baby. Okay. Got that one, got that one. The last thing I want to mention is the height. Here you go. How many of you guys have seen this one before? This is how high does the code require a receptacle to be installed off the finished floor? Anyone can tell me where in the code does it say how high a receptacle has to be installed? The code doesn't care about the height. I can put this receptacle as low as 6 inches off the ground, and that's okay. So this code doesn't care about the height. But there's different industries, guys, standards that really nice to every engineering firm has its own standard. What I want you guys to highlight this particular table. So for example, switches. Look at the switches. Regular, you can put your switches regular 46 inches above finished floor to center. Recommendation. And between counter and kitchen, here's your recommendation. And receptacle outlet 12 on center. Between counter and kitchen, you can put in 44 to 46. In garage, 46 inches off finished floor. Unfinished basement, 46. In finished basement, 12. Outdoor, 18 inches. That will be plugged with all the snow here in Minnesota. So these are all recommendations. All recommendation for height. Recommendation for height. Look at the lights. If you have a lighting, outdoor light recommended as 72, you put it right above the door to the side of the door. Any question, guys, about this? Any question about this? These recommendations actually are based on American with Disability Act too. People who are disabled, they need to be able to plug in things and turn light on and off. So that will also recommendation based on if you're designing a building, a public, now a house is not a public building. So it doesn't adhere to American with Disability Act. But if you're anything public, as you and I know, you have to adhere to the American with Disability Act. And there, they specify the height, the range that you need to put. These meet these ranges. Did you guys hear me? So you walk in with a wheelchair, you should be able to put it in a range where you can turn it on and off. Any questions? So this is not NEC, American with Disability Act, ADA. Any question? Any question, my friends? So please keep this in mind. What I always tell the people, guys, when you use it, these are great keynote or general notes where you say all receptacles shall be installed 12 inches above finished floor on center. So that's a good general note. There are two types of notes, guys. There's specific note and general note. So if I put a general note, all my receptacles shall be installed 12 inches of finished floor, all receptacles. Specific note, if I have a receptacle at the top, I put a keynote right next to it because I want my plasma TV to be 72 inches or say 55 inches. So I say keynote next to it. Receptacle shall be installed 55 inches or let's say 72 inches above finished floor. So we'll tell the electricians that this is exactly what I wanted. In residential, is not a big of a deal. In commercial, it is a big of a deal. Look at these receptacles at the top. How do I know that these receptacles when I'm looking at a blueprint? So imagine you're installing this and you're looking at blueprint 2D. How do you know that these receptacles at the top have to be at, what is it, 8 feet or so, probably? How do you know that unless it's keynote, right? So keynotes becomes very, very big deal for all of us.
Question, Chad.
Yeah.
Is Revit eliminating some keynotes now? Because again,
Yeah,
one
well,
view but you'd still want to have
yeah.
keynotes.
If you're doing 2Ds, if you're going 3Ds, if you're looking at this in Revit, it's clearly in a 3D format. You can tell exactly where this is. If you're looking at 2Ds, yeah, Revit is questioning all the 3D, 2D. If you're working on 3Ds, I don't need a keynote. I can show them all in 3Ds. But when you publish right now, a lot of people are publishing only 2Ds, then your keynotes become very handy. So, but eventually when a 3D modeling picks up, you're looking at 3D models, so you really keynotes, it defeats the purpose. That particular purpose. 3.16a, guys, you're familiar with this table. I promise you we'll talk about it one time. And 3.14.16b. These two tables when it comes to metallic box fill calculation. Metallic box fill calculation. Any question, my friends? Any question? That's what I picked this chapter, guys. I picked the most important things, which is basically the graphics in it. Chris, you ready? Anything that came across that need discussion that we missed? Anybody has anything, guys, in mind? So my expectation, guys, is you just read this chapter one time. Give a shot. If you read it, for the most part, the answers, the questions in the back is really straight from it. Some of them might be they're not using the right lingo, like the offset. But for the most part, you should be able to be there. Any question for your friend Chad?